Hello everyone, and welcome to another video in my channel. In this video, we are given x to power 8 plus x to power 4 all over x to power 7 plus x to power 5 is equal to 7 over 3. The condition is that x must be greater than 0, that is, x must be a positive number. How do we go about solving this problem? What we will do first is to reduce the problem so that we can solve it using quadratic equation. And to go about that, I'm going to divide the numerator and denominator by x to power 6. So I have x to power 8 plus x to power 4 divided by x to power 6. Then all over x to power 7 plus x to power 3 power 5 rather all over x to power 6 is equal to 7 all over 3. Now I'm going to turn these single fractions as numerator and denominator into two separate fractions. Now it becomes x to power 8 over x to power 6 plus x to power 4 over x to power 6 divided by x to power 7 over x to power 6 plus x to power 5 over x to power 6. Let's put this one in a bracket, is equal to 7 over 3. Next thing we'll do is to apply a law in indices. That is, a raised to power b divided by a raised to power c will give me a raised to power b minus c. I will apply it in each of the fractions. So it becomes x raised to power 8 minus 6 plus x raised to power 4 minus 6 divided by x raised to power 7 minus 6 plus x to power 5 minus 6. Let's remember it is equal to 7 over 3. Now x to power 8 minus 6 becomes x to power 2 plus x to power 4 minus 6 becomes x to power minus 2 divided by x to power 7 minus 6, that is x to power 1, plus x to power 5 minus 6 is x to power minus 1 equals to 7 over 3. Now turning these ones back to fraction, I have x squared plus 1 over x squared divided by x plus 1 over x is equal to 7 over 3. Now, the next thing I will do is to rewrite the numerator to be in terms of the denominator. So if I have x plus 1 over x all squared, I can expand it into x squared, that is x times x is x squared. Now x times 1 over x will give me x over x. Now 1 over x times x will give me another x over x. Now 1 over x times 1 over x will give me 1 over x squared. So it becomes x squared plus 1 over x squared, that is this one, plus x divided by x will give me 1, x divided by x again will give me 1. So this 1 plus 1 is 2, which is x squared plus 1 over x squared plus 2 is x plus 1 over x all squared. I will now take these two to this side. So I have x plus 1 over x all squared minus 2 is equal to x squared plus 1 over x squared. Now what I will do next is to substitute this for this. That is, where I have my x squared plus 1 over x squared, I'm going to write this in place of it. That becomes x plus 1 over x all squared minus 2 all over x plus 1 over x will now give me 7 over 3. I am going to substitute x plus 1 over x for y. So x plus 1 over x, we are going to make it y. Then where I see x plus 1 over x, I'm going to write y in place of it. So here becomes y squared minus 2 all over y is equal to 7 over 3. We are going to cross multiply. If we cross multiply, we have 3 times y squared minus 2 is equal to 7 times y. 3 times y squared is 3y squared. 3 times 2 is 6, so I have minus 6 here, is equal to 7y. And so 3y squared minus 7y minus 6 is equal to 0. We have a quadratic equation. Now, to solve this quadratic equation, we are going to use the factorization method. So here is 3y squared minus 3 times minus 6 is minus 18. I'm going to look for factors of minus 18 such that when they are added together, I'm going to get minus 7. Those two factors are minus 9y plus 2y, because minus 9y plus 2y will give minus 7y. Then minus 6 is equal to 0. If I group them, in the first bracket, 3y is common, remaining y minus 3. In the second one, 2 is common, remaining y minus 3 is equal to 0. Now, y minus 3, which is these two brackets, and then 3y plus 2 is equal to 0. So, equating each bracket to 0, I have y minus 3 is equal to 0, or 3y plus 2 is equal to 0. What I have is y is equal to 3, or y is equal to minus 2 over 3. Let us recall that the condition is that x is greater than 0. Since x is greater than 0, that means this will be rejected. But let's remember that y is x plus 1 over x. Therefore, x plus 1 over x is equal to 3 in the first case, or x plus 1 over x is equal to minus 2 over 3. We are going to reject this solution because the condition is that x must be greater than 0. So solving this one, x plus 1 over x is equal to 3. I will have to multiply through by the denominator, which is x. So if I multiply through by x, I have x squared plus 1 is equal to 3x. Then x squared minus 3x plus 1 is equal to 0. I cannot factorize this because the discriminant, which is b squared minus 4ac, is not a perfect square. So my b is minus 3. I have 9 here, and then minus 4 times 1 times 1, because a is 1 and c is 1. So what I have here is 5. So the discriminant is 5. Therefore, x equals to, applying the formula method, minus b, that is minus 3, plus or minus the discriminant, which is b squared minus 4ac, is 5, all over 2 times 1. Now x is equal to, minus times minus is plus, so I have plus 3, plus or minus root 5, all over 2. And so x equals to, x1 rather is equal to 3 plus root 5 over 2, and x2 is equal to 3 minus root 5 all over 2.